These are the solutions for the systems of equations assessment. So we'll start with the first one, which is one of the most challenging questions they could throw at you for this one piece. So it says there are two parking garages. Garage A charges $7 an hour to park for the first 2 hours. Each additional hour is $3. So when you do this, you can't say y equals 3x plus 7. I'll leave some space because those first 2 hours cost the $7, and then they're not charging you $3 at that point. So you have to accommodate for those first 2 hours. So you say x minus 2. So once x becomes more than 2 hours, then you've got your price point. If we were to talk a little bit more here about domain, you would have to say, well, x can't be used until it's 2. So your domain, if you were to list a domain, would be x has to be greater than or equal to 2. That is one of our pieces that's essential. They don't ask you to do that, but it wouldn't work if you had 0 hours, because then you have a negative number in front of the 7. Now your second one for garage B, they charge $3.25 an hour to park. So you would say y equals 3.25x. Okay, now determine algebraically the number of hours. Then you just set them equal to each other. It's a substitution problem because you know y equals y. So you could say 3 times x minus 2 plus 7 equals 325x. So you'll have 3x minus 6 plus 7 equals 325x. Subtract 3 from both sides, 3x. And you'll have these two combine, so you'll have 1 equals 0.25x. So you end up with $4 an hour. So, well, I'm sorry, in 4 hours, they'll both be the same. So in 4 hours, the cost will be the same. Now, interesting here, it says determine algebraically. So let's just suppose you couldn't write that equation up there. Write what you think is the best equation and do the algebraic work, and you might get some partial credit here. You cannot just kind of guess and check it out because it's not algebraic. All right, the second one, spent a lot of time talking about this ratio situation. At B's pet shop, the number of dogs is initially 5 less than twice the number of cats. So dogs is initially 5 less than twice the number of cats. So let's get our twice the number of cats in there. And if she decides to add 3 more cats and 3 more dogs, the ratio will be 3 to 4. So it asks you to write an equation that can be used to find the number of cats or dogs. So that ratio word is important because if she adds 3 cats, she'll have cats plus 3. If she adds 3 dogs, she'll have dogs plus 3, and the ratio is 3 to 4. Remember, cross multiplication is how you would solve a problem like this. So you would say 4 cats plus 3 equals 3 dogs plus 3. And you might as well just go ahead and solve it, although they did just ask for equations right now. You could just go ahead and solve it. So I'm going to do that now. I'll have 4c plus 12 equals 3d plus 9. And I guess I'll just leave it right there because I've got an equation. Could B's pet shop initially have 15 cats and 20 dogs? That word initially means at the starting point. Explain your reasoning. If she decides to add, so it says at B's pet shop, she had initially 5 less than twice the number of cats. So initially, I'm just going to plug into this equation. So dogs are 20, cats are 15. So 20 equals 30 minus 5. 20 does not equal 25, so no. That's the initial. Now it says determine algebraically the number of cats and dogs she had in her pet shop. That's after she added the 3 more. So I'll take these equations as they stand. Our dogs is cats minus 5, and then once they've added the 3 of each, and the ratio is 3 to 4, then I will pop that in, and I'll say, okay, so 4 4c plus 12 equals 3d is really 2c minus 5. I'll replace that d with 2c minus 5. I'll show that in green. And then plus 9. So we'll go ahead and solve this. So 4c plus 12 equals 6c minus 15 plus 9. 4c plus 12 equals 6c minus 6. I'll do these two steps in one now. So minus 6c minus 6c minus 12 minus 12. I'll have negative 2c right here. These cancel, equals negative 18. Divide both sides by negative 2. Cats equal 9. Dogs are 2 times the cats minus 5, so dogs equal 2 times 9 minus 5, so 13 dogs. Initially. Okay, on to our next. This problem talks about students on a swim team and on the chorus. And if you notice, they've given you a piece of information. They said X is the number of years since 2010. So I'm going to go ahead and label that now. Number of years since 2010. And then I'm going to see what are they talking about. They have members on their swim team, and the swim team is increasing and the chorus is increasing. So this would be Y would be our number of people. So it's worth considering what those variables are to begin with, because then you're able to write your equations better. So Central High School had 5 members on their swim team in 2010. So Y equals 5. The number of people in 2010 was 5. And it increased by 10 members per year. Well, X is the number of years since 2010, so it's 10X plus 5. And then for the chorus, they had 35 in 2010, and they increased 5 members per year, so 5X plus 35. So there's your system. Now you have to graph your system. So 10X plus 5, 5X plus 35. Now it's up to you. If you go by ones, you're going to run out of room. You want to go by something that will work pretty well. So I'm looking at 5 and 35 and thinking I would go by 5s on the y-axis. So I'm just going to say, okay, so that's 10, 20, 30. Oh yeah, I can fit that. So I'm just going to have every other one be our 10, and I'll say 10. Just to save me a little bit of writing. And then on the bottom, years since 2010, I'm probably not going to need to go by 5s or it'll be too squishy. So I'll just go by 1s for that same block. So it'll be 1, 2, 3, etc. Be real careful when you're graphing this. So when I'm graphing this, I'm going to say the first one is 10x plus 5. So we're going to start here. And the slope is 10. So we're going to go up 10 and over 1. Up 10 and over 1. So we have this nice kind of easy graph with no estimating. No need to do a dotted line. No need to worry about that. You're not dealing with an inequality. I don't have a ruler, so I'm just going to follow this right out to the end. Don't forget to label your line. And I'm going to call this the swim team. So it's clear. You could also say y equals 10x plus 5. And then for chorus is the 5x plus 35. So I'll start up here at 35. And I'm going to go over 1, up 5. So it's not quite as steep a slope. I can see they intersect right there. And I'll draw the whole line. And I'll call this the chorus. And I'll say y equals 5x plus 35. You can call it either. You can label it both. And then explain what has happened. So it actually never says you have to... Oh, no, it does. Explain in detail what the coordinate means in the context of this problem. So let's go ahead and say, what does this mean? So it's been 1, 2, 3, 4, 5, 6. So by 2016... right? Because it's years since 2010, so 11, 12, 13, 14, 15, 16. It means that they both equal out at 65 people. Both groups have 65 people. You could put the coordinates 6 and 65. That it doesn't specifically say that, but you could do that. All right, what is the solution of the system of equations below? You have y equals 2x plus 8, and you have another equation that's not in y equals mx plus b form. You could go and take the time to solve this right away, but you could also review that no solution means that they are parallel lines. That means they have the same slope, but a different y-intercept. Infinite solutions, that means they are the same line. And then two possible solutions. So I'm just going to simplify this one, and I'll have negative 6x plus 3y equals 12. I'll solve for y to get it in y equals mx plus b form. And I'll have y equals 2x plus 4. So now look at the equations I'm comparing. 2x plus 8, 2x plus 4. That would mean that they are parallel lines. They have the same slope and different y-intercepts. So this would mean there's no solution. And this is the most classic question that shows up for number 37. It's a pretty good question. For a class picnic, 2 teachers went to the same store to purchase drinks. One teacher purchased 18 juice boxes and 32 bottles of water and spent this much. The other teacher purchased a different amount. They tell you that juice boxes are J and bottle of water is W, so you don't need your own let statements. So 18J plus 32W equals 1992 for the first teacher, and then 14 juice boxes and 26 bottles of water are 1576. So 14J plus 26W equals 1576. Notice they just say write the system. They don't say solve the system right now. Now they say juice boxes could have cost 52 cents and bottles of water might have cost 33 cents. Use your system to justify. So there's a couple ways you can do this. You could just plug in and you could check those numbers in both equations. You could also solve your system. You could solve it. So I'm going to say plug in. You could solve using elimination and show that those are either correct or not correct. Or you could use your calculator, so I'll say TI Inspire, and solve. If you do that, remember you would want to swap out and mentally and say X and Y, and that's easily done, and then you just kind of correct to J and W. But they're saying they're not possible, so you are actually showing that it's not going to be possible. For now, I'll just do the plug-in, and I'll say 18 times 52, so 0.52, plus 32 times 0.33 equals 1992. So you just grab your calculator. 18 times 0.52 gives you 936. 32 times 0.33 gives you 1056 equals 1992. So add those together and you get 1992. So that works out. Definitely check the second one. You'll probably find the second one does not work. You can't just stop here. So I've got my 14 times 0.52, and I'll get 728, and my 26 times 0.33, and I'll get 858. I can already tell that is not going to be, but let's see, 1576, let's see, 7.28 plus 8.58. I end up with 15.86. So I'm going to actually write this. 15.86 does not equal 15.76. That's a pretty direct way to do it. I would say you're either going to want to plug in or use your Inspire. Elimination will work just fine. It's just maybe a little more work than you want to do for the problem. And the last problem, here's our system. Which one does not have the same solution? So you have a couple of options. You could plug into your Inspire and check them all, or you could look for some patterns. So here we have 1x plus 2y is 5, and 2x plus 1y is 4. So if these are multiplications of the original, then they will have the same solution. So 3x plus 6y, they've multiplied by 3, and that is just the top equation multiplied by 3. The bottom equation is the same, so that will have the same solution. So it says which one does not have the same solution. So let's keep going. The first one, they've multiplied by 4, so that is just a multiplication version. And the second one they have not touched, that will have the same solution. I should be putting X's through those. The next one has not been touched, and so that one is just the same. And the bottom one looks like it's 3 times, so this one will have the same solution. Let's hope the last one doesn't. So this one has not been touched. And then your last one, it looks like they multiplied the first term by 2. They multiplied the second term by 2. But the third term, they multiplied by 3. So this one is not a pure situation. It's not the same. So this one would not have the same solution.